Hey guys, U substitution day 2. There's like another kind of U substitution we can do, a little bit different. And it's kind of works when the other tricks don't work, like when you can't find the derivative of the thing in the integral. So we'll talk about that, but first I want to talk about the limits of integration. We might have talked about this a little bit in class, but normally we just switch it. We plug the x back in at the end, and then we just use that. But like when there's limits here, we're going to have to think about whether or not we want to do that. So here's one way to do it. So we're going to do U substitution, just off the rip here. And I'm going to choose U equals 4 minus x squared. In part because that's in the right, that's in the inside the square root, and the more when I always like to choose the thing that's inside the composite. Sorry, I can think of that word. So if I do this, then I get du dx is negative 2x. So du is negative 2x dx. I can see that I have x dx is sitting inside here, which is good news for me, my substitution. Because now I can really say negative 1/2 du is x dx. X dx. So like that's what I'm going to replace the x dx with. So I do negative 1/2 times the integral of the square root of u du. All right, just x dx got replaced with negative 1/2 du, and I put the negative 1/2 on the outside. The 4 minus x squared got replaced with u. This is negative 1/2 times the integral of u to the 1/2 du, which is u 2/3 u to 3/2. Sorry, so it's like 0 to 2 is the trick here, right? 0 to 2. I didn't rewrite that. I should have 0 to 2. So like I said, you add 1 to this, you get 3/2. Then dividing is like multiplying by 2/3. So it's like times 2/3 u to the 3/2. Evaluated from 2 to 0. But like you can't do it this way. Like you can't plug the 2 in for the u and the 0 in for the u. And the reason is that in my original problem, it was x's and dx's. And so these two limits here are like x equals 0 and x equals 2. So I can't plug them in for the u. So basically what you do, I don't really care. The numbers can all sit out front. Negative 1/2 times 2/3 is negative 1/3. Like what you can do, goodness. Is you like resubstitute. We've done that before. So it's really 4 minus x squared to the 3/2. Running from 2 to 0. And right, so when I put a 2 in, sorry, that's wrong, it should be negative 1/3. So it's the 3/2 power is a square root and then cubed. So I'm just going to write it like that. From 2, x equals 2 to x equals 0. And let's see. If I plug a 2 in, I get 0. Right, 4 minus 2 squared is 0, so that doesn't do much for me. Minus Then when I plug 0 in, I get 4 inside here because 4 minus 0 is 0. Square root of 4 is 2, and 2 cubed is 8. So 0 minus 8. So it's negative 1/3 times negative 8, which is 8 over 3. Okay. So that's method 1. And by method 1, I mean like we did u substitution. We replaced 4 minus x squared with u. We did the integration because it got easier. Then we replaced the u. We like replaced the u with the 4 minus x squared and then evaluated it. Here's the other way to do it. You basically do all of this stuff up to this point here, except this. Then we do the substituting. I'm just going to rewrite it a little bit of this stuff here. We said u is 4 minus x squared, which meant that du was negative 2x dx. We did all the substitution, and we ended up with this, negative 1/2 times the integral of square root of u du. Then we left the 0 to 2 on here, but to some degree that's kind of silly because that 0 and that 2 were x limits. So the smarter thing to do here is to just replace them with u limits. And you're like, well, how do I replace them with u limits? The answer is we have a little way to do that right here. Right, u is 4 minus x squared. So let's think about the upper limit. The upper limit was x equals 2, right there. Well, when x is 2, u is 4 minus x squared. Looks like I'm not equal to. I'm sorry. I'm having some lag problems with this computer, but we're going to just grin and bear it. U is 4 minus x squared, and if x is 2, u is 4 minus 2 squared, which is 4 minus 4, which is 0. So my upper limit was x equals 2, but when I have a u, when x is 2, u is 0. So I can just replace that with a 0. Now the lower limit was x equals 0. And now I can do the same thing. If u is 4 minus x squared, u is like 4 minus 0 squared, which is 4. So now I get a 4 down here. Now I can evaluate this integral the same way I did up here. I took the integral, right, and I got this negative 1/2 times 2/3 u to the 3/2. So negative 1/2 times 2/3 u to the 3/2. But this was a place before where I had a 2 and a 0, and I was like, you can't do that because those were x limits. But now I don't. I have a 0 in the top and a 4 on the bottom. A 0 on top. Oh my lord. 0 on top and a 4 on the bottom. And now I can just plug these numbers in. So it's still negative 1/3 out there. And then it's now, instead of going back to the 4 minus x squared, I'm doing the square root of u cubed. Running from 0 to 4. Which I promise is the same thing. It's 1/3. Let's see, I plug a 0 in, I get 0. I plug a 4 and a square root of 4 is 2. 2 cubed is 8. This sounds very familiar. This, of course, is going to give me the same answer. So basic idea is like you can do this where you like keep those x limits and then replace the u back with the x at the end and then plug it in. But it's usually smarter to change it to u, to change the limits to u's, because by definition, just about this thing we end up with is simpler than this thing because we try to make it simpler with the u substitution. So it almost always works out to be easier that way. If you want to put the x's back in at the end and use the original x limits, you can. I don't recommend it, but you should certainly do it. It's not going to be wrong. So I'll do another example here and talk about the other kind of substitution in the next video.